I'm going to start today's video by telling us a story. So the concept of pretest. Imagine a lecturer walks into the class without saying anything, decides to give a test to the students. Right? So that test is going to be pretty tough because the lecturer is coming in to take the course for the very first time and decided to give the test without preparing the student. Right? So we call this a pretest. It's done to check the level that the students are without the lecturer's intervention. So the next thing happens after the lecture. The lecturer intervenes by explaining some concepts and ideas around the topic for the students. And then immediately after the class, the lecturer decides to administer a second test, right? There is tendency that the students will perform better in the second test when compared to the first test. But we're interested in statistical significance. Now let's imagine after the second test, the lecturer says, all right, you can go home, but I want you to study the material I'm administering. Tomorrow, we are going to take this test again, right? So the students feel relieved, go back home, and spend the night studying. When they return, they now take the third test, right? Now, amongst these three tests, we have the pre-test, the first test, and the second test. Which one do you think the students are likely to perform best? Yes, the students are likely to perform best in the third test, right? Because they were taught and then later they had to study before taking the third one, right? So that's the test 2. Now, this is the concept of t-test. T-test tries to check whether the average scores of the students is statistically significant. We first look at the criteria for either saying that there is statistical significance. Now, this brings us to this concept. If the absolute t-stat is greater than the critical t, right, or the t critical, or if the p-value is less than 0.05, it means that there is difference, right? So there is statistically significant difference. Now let's understand the concept of t-test itself. We have what we call the paired sample t-test or dependent sample t-test. It's a statistical method used to determine whether the mean difference between two related groups or measurements is statistically significant. And the 0.05 you see here is nothing but the significance level. It tries to say there is 5% probability or risk, making a conclusion that the difference exists in these scores when they actually do not exist, right? That's how to interpret it. The third concept I want us to look at is what we call the two-tail or the one-tail, right? So if I say two-tail or one-tail. Now, two-tail means we're trying to check if the lecturer's intervention increases or even decreases the total score. That's what we call two-tail. So it's two directions. So that statistics is going to check whether the lecturer ended up making the students perform even worse than what they had without his intervention, or just checking if there is significant improvement. That's what we call two-tail. But one-tail is we're just trying to check. So for this particular class that we are looking at, for this particular scenario that we define for this student test, we are going to be looking at one direction. We know that after lecture, at least the score should go higher. That's what we're interested in. So it's one-tail, right? After the students studied for the test, is there an improvement? So still one-tail. Let's look at our data set. So you can see our data set is an Excel file. We have the student ID, the student score in the pre-test, the first test, that's immediately after the lecture, and then the second test a day after, or after giving the students opportunity to study. We can only perform the test between two variables, right? So we compare between the pre-test and test 1, and then run another one by comparing between pre-test and test 2, or test 1 and test 2. That's how to run a t-test. Now, we need to check something. We need to check how many students are there. There are 30 students. So there is a concept called degree of freedom. Degree of freedom is n, number of observation, minus 1. So that means we have 30 minus 1, which is going to be 29. Now, so our degree of freedom is important because it's going to help us to check our value if we are using a table. Now, this is what we call a t-table. Remember, our statistics is one tail. So we go to one tail and look at our significance level, which is 0.05. Our degree of freedom is 29. So we now go where 29 here meets our criteria, which is 0.05 in one tail, is this value. So our T critical is 1.699. That's how to get it using the table. T critical is 1.699. So please take note of this value because we are going to compare our t-stat with this. So to run the t-test, want to run between pre-test and test 1, what you need to do is to go to data, go to data analysis here, and then you select our t-test. So we go down and look for t-test paired sample, and then we say okay. Now it asks us for variable range, right? Variable 1 range. So we are going to put our cursor here and select variable 1 range. Then variable 2 range as well. You scroll back up and select variable 2 range. Then now we check, are there labels? So we check in our range, did we select labels? Yes, so we select it. Significance value is 0.05. Fine, everything is okay. We want our result in a new sheet. We click OK. Now we're going to have our result here. Take note of what I'm going to highlight, what we're interested in. We're interested in t-stat first, right? So let me highlight it in yellow. So these are t-stat. What's our t-stat? Minus 0.4403, right? So let me write it here. So our t-stat, let me write it in red. Our t-stat is minus 0.44. Let me just leave it like that, right? So minus 0.44. Now compare this t-stat and the critical value. Remember, we said that the condition there is that is the absolute value of t-stat greater than t critical? That's the question, right? So let's go back and see. This t-stat minus 0.44. The absolute value, we remove the minus sign. So 0.44. Is it greater than 1.669? That's the question. If it is, then we reject no. So it's not greater, right? 0.44 is not greater than 1.699. So that means there is no significant difference. We cannot reject null. Another thing is to check the p-value. If the p-value is less than 0.05, we reject null. Now we go back to our score sheet and look for the p-value. So this is the p-value for one tail. The p-value for the one tail is 0.33. Is 0.33 greater than 0.05? Yes. Is it less? No. So because it's not less, right? So two conditions are telling us the same thing, 0.33. So let me just write the values here. So our t-stat is 0.44. And our t-critical is 1.699. Then our p-value is 0.33. Right. So you can see the absolute value, 0.44, is actually less than the t-critical. Likewise, the p-value, which is 0.33, is not less than 0.05. So all are pointing at the same direction, that we do not reject the null, right? So we do not reject the null. If it was the other way around, we would have rejected the null. So that means there is no difference, right? The test that the teacher gave them before lecture and the one immediately after lecture had no statistically significant difference. Let's run the second one and see. So let's compare what the scores in test 1 versus test 2, right? And see if there is difference. Since there is no difference between pre and test 1, let's check test 1 versus test 2. So the same procedure, all we need to do is to go to data and click analysis, go to t-test paired sample, and then we select our range. This time around, the input range, we'll erase this and select this. So everything remains the same because the number of observations is the same. So we don't need to change our degree of freedom, and so our value does not change, right? So this is fine. Now let's show our result in a new table. Let me expand this so that we can see very well. So what do we have as our t-stat? Minus 14.4. But the absolute value, we remove the negative sign, is 14.4, right? So that's what we have. Now, see something. Let me change the highlighter. So the second one is 14.4, which is greater than this. So this one checks. And then let's look at the p-value. The p-value is for one tail here. So let me highlight it. You can see is 4.209, but exponent minus 1.5. This is a very small value, right? If we display it as numbers only, you see that is 0.00. Very small value, right? See 0.01, which is also less than 0.05, right? So this also checks. At the end of the day, the mean difference is significant, so we reject null, right? Because all these conditions have been met for the second instance. So that means our conclusion is that although the first test was poor, likewise the second test, there is no difference in the performance immediately after lecture, but there is statistically significant difference in the student's performance after they studied for the test. I hope you enjoyed this video.